Standards and regulations for wireless local area networks. A friend of mine once told me, he said, Keith, you know what the great thing about standards are? And I said, what? He said, the great thing about standards are that there's so many to choose from. And that is absolutely true. The question I have is, where do these standards come from? Who makes them up and who's regulating the use of these various protocols? Well, in this video, we're going to answer exactly those questions. Let's begin. Sometimes ignorance is bliss. For example, consider Bob, a happy user. And why is he happy? He's happy because he's able to go out to the internet. Let's say he's going to ESPN. He's happily surfing that site, watching video streams and whatnot. And he has no idea, really, about all the details that went into that. He doesn't know about ARP requests or DNS lookups or HTTP. All he knows is that he opened his browser and he went and connected. Now, behind the scenes, as you and I know, there's lots of protocols at work to make all of that possible. In the wireless space, there are certain protocols and rules that are going to happen at layers 1 and 2 of our protocol stack. In the wired space, there's also a set of rules that happen within a protocol stack. And what I'd love to do is chat with you for a moment about these groups. Who is it that's supporting us in creating these protocols and these standards for layer 1 and layer 2? And the answer is simple. It's the IEEE. Now, IEEE stands for the Institute of Electrical and Electronics Engineers. Within the IEEE, there's tons and tons of working groups. Now, you might say, well, Keith, great. What exactly is a working group? Is that a gang of people that all cooperate and get stuff done? And a working group's purpose is to write a standard for something. For example, several hundred years ago, we had no electricity, at least no organized and controlled electricity, so we didn't have to worry about wireless local area networks. However, as soon as we started figuring out radio frequency and how we could leverage this, there became a need. And somebody said, you know what, as far as wireless airspace goes, we probably ought to set some standards so we can build equipment and multiple vendors can build equipment and interoperate with each other. So really how this got kicked off, there was a project that identified there's a need. Then a working group was organized, and what they would do is they would study how the wireless might be used and how it might be implemented, and then they went to work to create standards and protocols that could be implemented for a given technology. So let's put this in perspective. Here we are at IEEE.org, and we're looking at the working group areas. Now, sometimes we think, okay, our area, our technology is the best, the most important thing going. However, IEEE is setting the standards wherever there's a common need in place. And even right here, it's saying it's not even a comprehensive overview. It's not all of them. So let's scroll down and take a look. There's just hundreds and hundreds of different working groups that they have set up. And if we take a look at this little guy right here for LAN MAN, so local area network and metropolitan area network, and we click on that, that'll give us more information on that working group. So here's the one, 802.3, that many people are very familiar with because that's the Ethernet standard for Ethernet networking, the primary protocol used on high-speed local area networks today. And we also have the 802.11 working group, which is for wireless local area networks. And they, my friends, the IEEE and that working group is responsible for setting up all those standards for the protocols. So regarding the frequencies, the encoding, the modulation, all that cool stuff that happens at layer 1 and 2 in the OSI reference model for wireless, those are all subsets of the 802.11 working group. At standards.ieee.org, we can actually download the standards. So if we want to see the details for 802.11, we can go ahead and download them for absolutely no charge, which is pretty darn cool. So here it describes a basic service set as the building block for IEEE 802.11 wireless local area networks. And if we scroll down a little bit further, it explains that the independent basic service set can be used as an ad hoc network. So these terms like IBSS and ad hoc network for wireless local area networks, we didn't just invent them. The IEEE came up with those as protocol standards, and that concept and those terms have been implemented by the various vendors. If we scroll down a little bit further, it introduces the concept of a distribution system. And it's saying instead of operating independently as an ad hoc network, we can use an infrastructure basic service set or possibly multiple basic service sets. We're talking about multiple APs that can connect to a wired network and to points beyond through a distribution system. So this gives us a great opportunity to review some of those basic concepts that we learned in the terminology and topology video. So if we scroll down a little bit further, it introduces the idea of potentially using an access point So this distribution system could represent the backbone or the core or wired network that we currently have. Then we have access points. Each of them has a cell that are supporting their customers. So here we have 2 different cells or basic service areas, also termed right here as BSS, basic service sets. So that customers associated with this access point here or this access point here could then get access to the rest of the infrastructure through the distribution system. If we scroll down a little bit further, it mentions that we could have an extended service set, which would give us the ability for customers, whether they're connecting here or here, to be able to connect to the same SSID that is being maintained across those different areas. Now, not only does this talk about the basic terminology and concepts, but it also goes into great detail about the other protocols involved with wireless local area networks, including security, the modulation methods used, including frequency hopping spread spectrum, DSSS, as well as OFDM, which are 2 different modulation methods for encoding data in a wireless network. And for people who are really eager to see about the nitty-gritty of everything there is to know about wireless, these types of documents are a great resource to dig into. So in this video, we've identified so far that the IEEE and its working groups are responsible for Layer 1 and Layer 2 protocols for wireless local area networks. They basically look at an area where there's a need, they identify the potential or needed uses for a technology, and once they've studied those applications and their uses, they'll then publish protocol standards regarding the modulation, frequency, framing, physical. So effectively, everything at Layer 1 and 2 that need to be set up as standards, it would be the IEEE publishing the standards and then vendors following those standards to implement the technology. So here's our next challenge. Let's say that you and I go into business together. We get some venture capital money. We get the protocols from IEEE and we make a few 100,000 access points. And we're excited. It's great. It's like, we manufacture them, we get them rolling out, we sell them. And then some other company is making hundreds of thousands of network adapters for computers, maybe built-in ones in laptops or add-on cards or USB ones, you name it. And unfortunately, we start getting trouble tickets that come in saying, hey, this access point, we can't connect to it, we can't authenticate, we can't associate with it. And we start digging into it and we find that there's an incompatibility between our access point and some other vendor's wireless network interface card. Now, how can we solve that? Now, initially, a lot of times companies will say, it's their problem. We follow the standard. They didn't. The reality is the customer could care less. The customer just wants the functionality to work. They paid for their devices. They expect them to operate. How in the world do we have a whole bunch of different companies all trying to follow the same standard? How do we verify that they can interoperate correctly together? And the answer is we have some third party that can certify our products to a set of standards. And that third party regarding wireless local area networks is this group right here, the Wi-Fi Alliance. So here's what you and I could do. We could take our access point that we spent all this money and time building and take it to the Wi-Fi Alliance along with a big hefty check, and they would go through our product in their labs and they would certify it based on, for example, 802.11n or 802.11b or G or A, whatever the specification is we are trying to achieve with that product. They would run it through the test and then give us a stamp of approval if it met the standards. So when it says AC, it's referring to 802.11 AC. Now the IEEE are the ones that came up with that. But if you're making a product, or if we're making an access point that supports it, that's a very, very high-speed wireless local area network. It operates in the 5 gigahertz range. It's supposed to be close to 1 gigabit per second, which for a local area network wireless, it's absolutely amazing, the leaps and bounds that we're making. So if that's the type of access point that we're building, we would want to pay that money to have the Wi-Fi Alliance certify it. We get their stamp of approval. We can put the logo, the Wi-Fi certified logo on our product. And then in theory, anybody else who's making an 802.11 AC product, such as a wireless network adapter, those 2 devices should, if they're both certified, be able to interoperate with each other. So let's back up and make sure we have a whole picture of this. The 802.11 group and the subsets of the 802.11 are responsible for analyzing and then creating the actual protocols that can be implemented. Once those protocols are set in paper, it's up to the vendors to go ahead and implement those protocols. As they do so, they take their products to the Wi-Fi Alliance to be certified by the Wi-Fi Alliance by their set of testing guidelines, And as a result, we have intercompatibility between different vendors who are both following the same protocols. So let's say we have these access points that your and my company made. They're great. They're working fantastic. Maybe the wireless LAN controller was built by a third company. It's working with our access points. And the stations, these wireless stations, their wireless network interface cards are associating with our access points, and life is good. Now, what happens if somebody, this is our building, what happens if somebody next door, right over here, has a radio? I'm talking, I don't mean like an FM or AM radio. I'm talking about a radio transmitter, and they're also using channel 6. What happens if they send their signal so strongly that it starts interfering? What would that feel like? Well, if you have two different radios and they're both sending on the same exact frequencies, there's likely to be some competition or collision. In fact, it would sound something like this. One of my very dear friends, Jeremy Chara, is another trainer at CBT Nuggets. What I'm going to do is I'm going to play a little snippet of one of his nuggets, and I'm going to talk at the same time and see how much you can pick out of either of the conversations. So as Jeremy talks, he's going to say something fascinating, something really important. However, maybe my message is just as important. It just depends on who the listener is and what the topic is you're interested in. However, you can see from this demonstration that having two senders at the same frequency or at the same time, it's very, very challenging for a human to keep track of it. And with radio frequency, when we have two different devices sitting at the same time, it's trouble for the network as well. One of the things that we're going to have is regulatory bodies to help enforce the fact that we're not abusing the privileges. For example, there are limits to how much power we can send a given signal on. We're all sharing these frequencies for the wireless local area networks. We need to make sure we're not sending too much or further than the standard allows that might interfere with someone else. In the United States, we have the FCC, the Federal Communications Commission, and one of their many responsibilities is the wireless space that we're going to be using inside of wireless local area networks. It is very likely if we're buying products off of the shelf and we're not intentionally manipulating or changing their behavior, the signals that they're generating, for example, an access point, are going to be within spec and not be a problem. Now, that being said, individuals can also take, for example, an access point, install a rogue or a different flavor of operating system on that access point, and start sending out a signal at a higher rate than is allowed by the FCC. It's always a great idea to stay within the law. So the FCC is responsible for defining things like how much power. They aren't going to specify, for example, the actual technology that's being used. That's the IEEE's job. However, how many milliwatts of power we can use as we start generating that radio frequency and what frequency we can send on, those are all within the realm of the FCC. In different countries, there's different bodies. For example, we have the European Telecommunication Standards Institute. In Japan, they've got the Telecom Engineering Center. In India, they've got the Broadcasting Regulatory Authority of India, and the list goes on. It's important to follow the rules in the country where you live. One scenario that I ran into is in Europe, and I had an access point from Europe. It was a Cisco access point, and I brought it back to the States. Well, that's not illegal or anything else. However, that access point supported a 13 as a channel that I could use as a center frequency in the 2.4 gigahertz range. Well, in the US, we go up through 11. 1, 6, and 11 are the three center channels that we'd be using in that space. Well, this access point supported 13 because 13 is supported in Europe. So legally, I wouldn't be able to use that channel here in the United States. The other issue is about supporting a channel like this of 13 in the US where it's not allowed is you'd have to make sure you had clients that also support that channel. The reality is the 2.4 gigahertz range is very, very busy. So with technologies like 802.11n, we have the 5 gigahertz range that we can play with, and there's lots of space up there. And as a result of having additional space in the 5 gigahertz range with 802.11n, we really wouldn't need to worry about using an unauthorized channel in the 2.4 gigahertz space. We could simply find a free channel up at the 5 gigahertz range. In this video, we've identified that at layer 1 and layer 2, the IEEE 802.11 group and subsets are responsible for the protocols of wireless local area network. They set the standards. They take a look at the use and the possible application, and then they make the protocols. It's up to vendors to create the products. They get them compliance tested with the Wi-Fi Alliance, and then the operation of these wireless devices are going to fall under the regulations in the country where you happen to reside. I've had a great time in this video with you. I appreciate you spending the time with me. I hope this has been informative for you, and I'd like to thank you for viewing.